Our planet is mostly water, over 70% of its surface actually. But get this, we've explored, mapped, and even just observed less than 20% of our own oceans. It's this whole other world of incredible resources, unbelievable power, and just so many mysteries. Okay, let's dive right in. To work in this world, you have to operate in one of the most hostile environments you can possibly imagine. We're talking about complete pitch-black darkness, temperatures near freezing, and pressure so immense it can literally crumple a submarine like a soda can. So that brings up a pretty important question, right?
And that right there, that's the core problem. That's the fundamental challenge for an entire field of science and technology. And the answer? Well, the answer lies in the incredible work of ocean engineers.
Now, when you hear the word ocean, what do you think of? Your mind probably jumps straight to dolphins, whales, and beautiful coral reefs. And hey, that's totally fair. But that's also where a really common misunderstanding starts.
This quote from ocean engineer Brandy Armstrong just hits the nail on the head. The focus for an engineer isn't on the animals themselves. Nope, it's about the entire system they live in. The physics of the waves, the chemistry of the water, the geology of the seafloor. That's the engineer's playground.
So here's the key takeaway. Oceanographic engineering is basically the technical backbone of all marine science. These are the folks who design and build the tools, the systems, and the tech that lets us understand that huge, complicated marine environment to begin with.
And this comparison makes it crystal clear. A marine biologist studies the fish. An ocean engineer designs the autonomous submarine that can follow that fish into crushing depths, take water samples, and beam all that data back to the surface. One studies the what, the other builds the how.
So what does building the how actually look like day to day? Well, it's this really fascinating mix of super high-tech computer work and rugged, hands-on problem solving.
It's an unbelievably diverse job. Seriously, one day you might be in an office writing code for a complex simulation of ocean currents, and the next, you could be on the deck of a ship in a storm deploying a sensor array you designed. You really have to be a jack of all trades. Now, this is really cool because it shows you how a core engineering task actually works. Building a computer model of the ocean isn't some plug-and-play thing. It's this whole creative process of picking the right tools, feeding them the right info, debugging like crazy, and, this is crucial, constantly checking your digital world against the real one. It's just a cycle of refine, refine, refine.
All right, so how in the world do they pull all this off? Well, to solve these massive challenges, ocean engineers don't just use, they actually create some of the most advanced technology on Earth. Just think about this for a second. Imagine you have a long line anchored to the seafloor, with a buoy on top, and it is just loaded with millions of dollars of one-of-a-kind sensors. A hurricane is coming. What do? You can't just go get it.
The answer is so smart. You unleash the full power of a virtual hurricane on your design long before it ever even touches the water. This is where engineering becomes like a superpower, predicting the future.
They use this amazing software that's kind of like a video game for engineers. They can build their entire setup from a library of real-world parts and then just throw everything at it. Digital wind, waves, currents. They can see if a buoy will get pulled under or if a giant wave will create a sudden snap load and break the line. This saves millions in lost gear and makes sure that priceless data gets home safe.
And the toolkit is just massive. It's everything from these incredible deep-diving robots, like AUVs that swim on their own and ROVs that are piloted from a ship, to powerful sonar systems that paint a detailed picture of the ocean floor, and even satellites that give us the big picture from space. So we've got the what they do and the how they do it. But the biggest question is, why? Why does this work matter so much to every single one of us, even if you live hundreds of miles from the coast?
Well, for one, renewable energy. As we search for sustainable power, the ocean has massive potential. Ocean engineers are the ones on the front lines, designing these gigantic foundations and structures for offshore wind farms that have to withstand the constant, brutal punishment of the sea. And think about our coasts. With a changing climate, they're more vulnerable than ever. It's ocean engineers who are figuring out how to design the seawalls, breakwaters, and other structures that protect entire communities from flooding and erosion. Their work literally saves lives and homes. And of course, there's just the pure pursuit of knowledge. Every mind-blowing discovery in the deep sea, from hydrothermal vents teeming with life to bizarre new creatures, all of it was only possible because of the tools, vehicles, and systems that ocean engineers created. They are the ones who make exploration possible. But what about the people themselves?
This isn't a job you can just do from a comfy office chair. It takes a very special kind of person with a unique kind of grit. I mean, just look at the reality of fieldwork. We're talking months away from your family, working crazy long hours, 7 days a week, all while living in tight spaces and dealing with violent seas. It is incredibly demanding, physically and mentally. You have to be passionate about the mission.
And on top of all those physical challenges, there can be cultural ones too. As Brandy Armstrong points out here, even in a field this technical, gender bias is still a real thing. It's a powerful reminder that building better technology has to go hand in hand with building a better, more inclusive community.
And that's exactly where the solution is. It's not another piece of hardware. As the problems we face get bigger and more connected, the need for teamwork, for different perspectives, and for strong mentorship is more important than ever. That's how the whole field moves forward.
So when you put it all together, it becomes really clear. These engineers aren't just building boats or gadgets. They are literally designing our ability to understand, work in, and sustainably use the most critical and most unknown part of our planet. They really are the architects of our last frontier. From energy and food to the very stability of our climate, so much of our future is tied to the ocean. So the crucial question that leaves us with is this: who's going to be the one to step up, design the solutions, and engineer the key to unlock that future for all of us?